So I just made a whole video on this, but my mic wasn't recording, so it's crushing. All right, back to the drawing board. All right, we're asked to compute marginal revenue. So that means you want the derivative. Marginal revenue means how fast is the revenue changing at an instant. So the derivative. So to do that, we need the quotient rule. It's the derivative of the top function times the bottom function kept the same, minus the top function kept the same times the derivative of the bottom. They listed the quotient rule for you right here. Now the derivative of the top function, we'll call that f prime for short, is 0.4 times 200 e to the 0.4x. Okay, because when you take a derivative of an exponential function, you're using the chain rule. You take a derivative of the innermost function, 0.4 is the derivative of 0.4x, right? And that multiplies on the outside, okay? And then the exponential function actually stays the same after that. You keep it as e to the 0.4x. So anytime you got a variable in exponent, take a derivative of anything in the exponent and multiply that outside, but then keep the exponent the same. Okay? If the base is not e, then you'd multiply it by a natural log of the base. Okay, so if that was 2 to the power of 0.4x, then my derivative would be 0.4 times 2 to the 0.4x times natural log 2, because 2 would be the base there. Okay, but that's a derivative of the numerator, and I already did this because this is the second time I've done this problem now. That's 0.4 times 200 is 80. So when we do this derivative, it's the derivative of the top function. Oh, they used u and v. I used f. I hope that doesn't confuse you. That's just, you could just replace that with u. Okay. So it's the original first function times the derivative of the second. So that's 1 plus x is the denominator times the derivative of the numerator function. That's 80 e to the 0.4x. Okay, so we're done that part. Man, I wish you could have heard me earlier. The first time was way better. Now it's times the original numerator. So it's 200 e to the 0.4x times the derivative of the denominator. Look, the derivative of 1 plus x is just 1. So that's the second term. And it's all over the denominator squared. Okay, that's the derivative. We're asked to find the values that make the marginal revenue negative. Where is this derivative negative? So you want to know where this derivative is less. Wait. I want it negative, so it should look like this. Here's a better way of doing it. Let me copy and paste that so I have some room. You want to know where the derivative is less than 0, right? Where it has a negative marginal revenue. So to solve this inequality, you multiply 1 plus x squared to both sides. But that's going to make it cancel out here like we wanted because we want to get rid of the denominator. That makes 0 over here. So we're left with 1 plus x times 80 e to the 0.4x minus 200 e to the 0.4x. That needs to be less than 0. So let's distribute. 80 times 1 is 80, and all that other stuff that came with it. And then x times all this stuff, that makes 80x e to the 0.4x. And now we can combine like terms. You got 80 e to the 0.4x minus 200 e to the 0.4x. That makes negative 120. So I'll put that over here. You could put it out front. So it's negative 120 e to 0.4x. So to finish solving that equation, I'm noting that we have e to the 0.4x in all these terms. So let's divide everything by e to the 0.4x. That'll make it a lot simpler because once you're done that, you're left with just 80x minus 120 is less than 0. So there's one last step. two last steps, I guess. Add 120, divide 80. So you get x is less than 1.5. So the full correct answer using this restriction at the beginning is that x is between 0 and 1.5. I wish you could have seen the temper tantrum I pitched when I realized that my audio wasn't recording. Okay. I've also done this one twice today now. It's so sad. We're supposed to find the marginal revenue at x equals 2, so we need a derivative again. So this one also needs the chain rule. Look, imagine this is all x. If it was x to the fourth, the derivative would be 4x to the third, right? So that's what the chain rule says to do first. It's 4, but instead of x, we have this whole mumbo jumbo inside here. We're leaving that alone. Just the power rule, right? 4 came down, multiplied, got reduced by 1. But the chain rule says you need to multiply this by the derivative of the inside of that function. So term by term, the derivative of natural log x, they tell you right here. Derivative of natural log x is 1 over x. The derivative of 2x is 2. There's our derivative. There's our marginal revenue. Okay? And they want to know the marginal revenue at x equals 2 and round to the nearest integer. So we're taking the derivative, but we're plugging 2 into it. So we just need to know what this is when we plug in x equals 2. And I see I already did it. It's 1034. Okay? That's the marginal revenue at x equals 2. Plug in x equals 2, and that's what you should get when you round to the nearest integer. And that's it. So this thing, their revenue is increasing by $1,034 per time period. Per x, I guess. I guess I don't know what x is because they never said. But final one here. I tried to do the hardest ones. This one's pretty easy. Financial director of a table production company finds that the marginal revenue. Okay, they got the derivative for us. What is the correct interpretation of the marginal revenue when x equals 10? You just have to plug 10 in there. So 10 times 30 makes minus 300. 500 minus 300 makes 200. So the marginal revenue is 200, which means that when 10 tables per week are being produced, their revenue is increasing at a rate of $200 per whatever time unit they are. This is correct so far, which means that it costs $200. No, this is revenue, right? That's telling you how much money you're bringing into the company, not cost. Marginal revenue is 200, which means that each table is sold for 200. No, this they didn't explicitly say that revenue is simply just tables. But what it means is how much revenue do you have overall for your company. The overall company revenue is $200 per time unit. The marginal revenue is 200, so we got that, which means that each table gives a profit of $200. Marginal revenue isn't saying how much profit you have because it's revenue. Revenue is how much money you bring in before you take out expenses. Profit is how much money you have after you take out expenses.